Hello my dear students, I am Pandey, your physics lecturer. Here you are in series of lecture video, and in standard 11 we have reached to the lecture number 37. My dear students, in last lecture we have done the very special class. It was based on numerical question of chapter friction. Today we will solve few more numerical of friction and then we'll conclude. Hopefully from next lecture we will move to the circular motion. Alright, so let's start today's lecture my dear students. It is lecture number 37. And the same chapter it is friction. Remember, you can understand, you can suppose this is the second lecture, that is the second part of the lecture number 36, which was based on the numerical. Alright my dear friends, so let's start today. This is the numerical special class. Alright, so the first numerical of today's lecture, my dear students, it is of pulley mass system. At the surfaces, rough and pulley is applied by a force. Surface having mu 0.1, okay, surface, and the body having the coefficient of friction 0.1. This pulley is massless. Now my dear students, if we apply here the 10 Newton of force F, it is equals suppose it is 20 Newton, then you have to find acceleration of m. If this m is 10 kg, alright, you have to find the m. The length of the string is sufficient so that you can consider the acceleration of the string. Alright, you have to find the acceleration of this mass if the force is being applied by 20 Newton. The coefficient of friction it is 0.1. If you can solve this question my dear students, try to solve by yourself. So let me solve this question my dear students. Here first we have to see this body of mass m, how much friction force it can apply for the static friction. Alright, here if this string with a tension T, let me draw here the free body diagram, tension T. If this tension T try to pull this mass as a driving force, of course there will be the friction force in this direction, F. What should be the value of this F, my dear students? It is the mg, and this is the normal. F, we know that it is mu times mg. Alright, yes. And mu, it is 0.1. So 0.1, and this is 10 times 10 100, which is 10 Newton. Alright, my dear students, it is 10 Newton. How much friction force applied? It is 10 Newton to oppose the motion. Now look at here. Here the 20 Newton of force is being applied. The 20 Newton force is being applied. So how much this tension? We know that is 2T will be equals F. So T will be 10 Newton because this F is 20 Newton given in the question. If this T is 10 Newton, that we have calculated whether the body will move. If it is the static friction, then body will not move at all. Alright, so our answer, the acceleration will be 0. The acceleration will be 0. Remember, this is the answer. But my dear students, if we will change slightly this data, we will have the acceleration. Suppose now This is the answer. Remember. Now, I've changed this question. Suppose now the 25 Newton of force is being applied, or the 30 Newton of force is being applied. Alright. If this F is now 30 Newton, we have changed this data. Now F is 30 Newton. Then what will be the acceleration? Could you find, my dear students? This is your homework. This is your homework. If this F is 30 Newton and all the data are same, then you have to find acceleration of this block. Alright, this is your homework. Okay, so let me write here the next question. Now the second question, my dear students, I'm drawing over the board here. This is the multiple body problems. This is 2 kg and 4 kg. Suppose A and B. 2 blocks are kept over the surface. Conditions are given that I'll give you. Here the 10 Newton of force applied on A. 10 Newton of force I'm applying on A. Coefficient of friction for this surface it is given 0.1 and for this surface it is 0.2. Alright, 0.2 between 2 kg and 4 kg, 0.1 between surface and 4 kg of block. What we have to find? You have to find acceleration of both the blocks. Suppose A1 and A2. You have to find in last lecture, my dear students, we have solved few questions or it might be the one question of this type. Alright. So if you can solve, my dear students, try to solve this question. Otherwise, I'll give you the answer. I'll solve this question for you. Alright. Now, let me solve this question. Here, as we have discussed, we will proceed today again. First, to find the acceleration, we have to think whether this force is sufficient to pull this block 2 kg over the block B, and yes, if it can pull, then whether this B will also move. So let me draw here the free body diagram. Remember, the free body diagram is very important. We have learned from the laws of motion, the SAFI. Okay, here the 10 Newton force applied. Alright, the 2 kg, it is the 2z, and here it is 4z. Alright, yes. Once this applied force, that is the driving force, will act, it will pose by the friction F1. Of course, this will be driven by F1 because this is conjugate force. Remember, my dear students, if you are not getting this particular thing, kindly go to the previous video, lecture number 35, 34, 33. In all lecture I have explained while teaching this friction. Alright, so this F1 will work as the driving force for this block B. Alright, this is the block A and this is the block B. This F1, that is the friction force, will act as driving force for this block B. Now, if this block is moving, suppose if this block is moving or try to move, then there will be the friction force, and suppose it is F2. Now we will check first the condition, then after we will able to find the acceleration as well. Right? So here are the condition to move this body A over the B, that 10 Newton should be greater than F1. So we have to find F1 first, and F1 is nothing but the mu times mz. It is 2 times z. Alright, mu how much? It is 0.2. mz, that is 2 into 10, it is 4 Newton. Of course, this 4 Newton is less than 10 Newton. It means body A, block A, will move. With which acceleration it will move? So let us find. This is 10 Newton, opposing force 4 Newton, and moving with an acceleration A1. So we can write the equation, my dear students. It is 10 minus 4 is equals to 2 times A1. And A1, it will be the 6 over 2 3 meter per second square. Alright, now the second one for body B. This was for A. For B. My dear students, now you have to check. What you have to check? You have to check whether this driving force F1 is capable to move this body. So F1, we know that how much it is, 4 Newton. Now try to find out the F2. So F2, it will be mu times again mg. How much mg? If you will find the normal over this body, you will get the total mass added. It is 6. So 6g, and it is equals how much this mu? Mu is 0.1. So 0.1 times 60. So it is 6 Newton. Alright, it is 6 Newton. And you can see, my dear students, this force which is 6 Newton, which is less than 4 Newton. So how is it possible that it will drive, it can move this body? It is not possible. Remember, my dear students, in this question we can change the data and we will have the different answer. It might be for any data, if you will increase the value of this, change the friction, this is mu, it might be the body will start move this to body. Alright, okay, so let me wrap this one. Now the next question we are going to solve here. It was the 10 Newton applied. Let me make here the one homework from this question, my dear student. We have applied this was as 2 kg and 4 kg. We have applied 10 Newton over this one. If we apply 10 Newton over this body, then what will be the acceleration of both the block A1 and A2? You have to find. Alright, you have to find. All the data are same. It means the friction force over there 0.1, 0.1, here 0.2. Now this is your homework. Kindly note down, my dear students. You have to find the acceleration of both the bodies. Now next question. Next question we are going to deal here from SC Verma. Alright, from SC Verma. Let me grab this question. Okay, after drawing that question we are going to solve. I will wrap this one. My dear students, here you are having question from SC Verma. You can find out the question in book. Remember, what may be the edition of the book? Actually, year of the book. It has been not edited. SC Burman in 1992 he has written the book, and till now it is same. There is no edition on in that book. My dear students, if two block begin in this way with the help of pulley, it is connected. Remember, the pulley is massless and frictionless. Now we are going to apply here the mass, suppose m, small m and capital M. Here the friction, this is frictionless, mu is 0, but here the friction between this two body, it is mu. Now you have to apply a force. Alright, now the question, for what value of F max that you have to apply? What should be the maximum force applied? What maximum force can be applied? System remain in equilibrium. Alright, system remain in equilibrium. How much maximum force we can apply? This is the question. Could you solve, my dear student? If you can solve, try to solve it. Alright, let me solve this question. First, we have to see both the blocks individually. Remember, here, of course, there will be the tension T and T. Alright. If we are applying here the force F, of course, this body try to move in this direction, and the friction force will be in this direction. If there is a friction force over this mass M, so on capital M, the friction force will be in this direction. I hope you understand. Now, if this tension is capable to move this, drive this mass capital M, then there will be the friction force from bottom. But here the mu is 0, so no friction force will be considered. Now, since system is in equilibrium, remember in question it is, consider the system is in equilibrium. If system is in equilibrium, my dear students, it means this body is in rest, and this F, the maximum F, will be balanced by T plus friction force. So for M, we can write, what we can write, my dear students? F, it is equals to T plus friction force. Alright. Now, for this capital M, what we can write? If it is not moving, then friction force will be equals to the tension. Alright. Now, put the value of this tension in this equation. You will have the F is equals to T, or the T equals to F. So the F plus F, it is twice F. Am I right? Yes, it is twice F. Now, from here, the weight of the body, it is mg, and the normal reaction, it is N. So, my dear students, we can write here the N is equals to mg, and F can be written as the mu mg. It means the maximum force that you can apply even after the system remain in equilibrium, it is 2 times mu mg. This is the answer. Now, remember, my dear students, the question is not over here. The question is being continued. In a Sivama, wormers are asking if we will double this force. If we will double this force now, what we got? That is the 2 mu mg. Alright. Sorry, here. How much force we got? Yes, 2 mu mg. If we double this force, then what will be the acceleration? If we will double this force, then what will be the acceleration of these two masses? This is the question. Alright. And you have to think over this question. If you can solve this question, if we will double this force, that is, now it is 2F. It was F, now it is 2F. If we double this force, then what will be the acceleration of these two blocks? Suppose the acceleration A1 and acceleration A2. You have to find the value of A1 and A2. So, my dear students, I think I should leave this question for you for homework. Alright. So, this will be your homework. Try to solve. Let me write the question again in detail. What is the question? So the question is, this was the F max. Alright. What we got F max in first situation, you can rewind the video and can see it was F as 2 mu mg that we calculated. Now in this question, this is your homework. The question is, if F is equals to 4 times mu mg, then what will be the acceleration of two blocks? You have to find A1 and A2. Alright. And the systems are connected in this way. This tension I have been written for solving this question for myself. Alright. Okay. Also you can find the force on this wall. Okay. Now the next question. Let we discuss the next question, Zenius. Now, the question we are having, again, the two block, that is the multiple block problem. Alright, here 1 kg, that is above 1, and 3 kg below 1. Suppose it is A and B. Now, the coefficient of friction, it is 0.2, and here again 0.2. It is same at both the surface. Now the question, how much maximum force we can apply? What should be the maximum force that we can apply, for which body A, remember, body A does not slides over the body B. Remember, this is the question. For what value of F max A does not slides on B? This A does not slides on B. Alright. Oh, you can say in another word, or A and B moves with common acceleration. Remember, this is not the condition that whole the system should be in equilibrium. The condition is A should not move over the B, but this entire system move with common acceleration. I hope you understand this question. Okay, so let me find the answer. If you can solve, my dear students, try to solve this question. Okay, now let me solve. Remember, my dear students, the condition is given what? The condition is given that A should not move over the B. Alright? It means the entire system will move within a common acceleration. Suppose this acceleration is, the common acceleration is A. Alright, how much force we are applied here? F max. Suppose it is F that we have to find. So by this force, the entire system, it is moving with an acceleration A. Then what we can write? Remember, if this body is being applied, try to see individually both the body. That is our prime word. Alright, here we have given F that we have to find. Of course, if this body will move, that is the B will move in this direction, there will be a pseudo force. How much pseudo force? The entire acceleration, that is the acceleration of the frame, and mass of this body, that is 1 into A. Of course, if this body is moving backward direction, there will be a friction in this direction, F, and if there is a friction in this direction, what will happen? This body tried to drive this block B in this direction. Remember, it tries to drive. It is not necessary that it will drive in backward direction. So it will apply a force F, because friction force is a conjugate force that we have discussed every time. Alright. Now, since this entire system, this one is not moving but try to moving, so there will be the friction force, that is this friction force, that is the static friction force, but this entire system is moving. Of course, there will be a friction force F. Suppose it is F1 and it is F2. Now, first we have to write the equation for the acceleration, because both the system it is moving. Now look at here, both the system it is moving in acceleration A. What we can write, my dear students? In forward direction, the force it is acting F, that is the driving force, minus which one is the force trying to stop this entire system. Look at here, this is not the force trying to stop the entire system, but this force is trying to stop this one, but this F2 is trying to stop this entire system. So minus F2 is equals to, alright, minus F2 is equals to how much? It is mass times acceleration. Could you write, my dear students? Are you getting me? Why is it so, my dear students? Because it is not possible for anybody simultaneously having two direction motion in two direction, like this one. If this body is in equilibrium, that is in a static state with this body B, then of course it will have the common acceleration in this direction. Alright, in this direction, the common acceleration. Why? Because here the force it is acting due to the pseudo force. Of course, if it is trying to move along this direction due to the pseudo force, so it will not have the motion relative this body be in this direction. Alright, so this force cannot be considered. Of course, here the force will act, but individually, if you are considering both the body. I hope you understand, my dear students. Now look at here. We have written the equation to the mass time acceleration, that is the acceleration we will try to find out, but it will the mass times acceleration. And how much the mass of this body? Of course, this body will have the entire system, it is moving with some acceleration. It is mass times m1 plus m2a. Alright, so it is f minus f2 is equals to m1 m2, it is the 4 times a. This is the first equation. Now, what should be the condition of motion of this A over this B? So, of course, if it is applying here a frictional force, if this applying frictional force will be smaller than the pseudo force, of course, it will move. So, for the condition to be in static state, these two should be equal. For 1 kg, we can write, my dear students, it is as F1 as it is equals to, I think this one, yes, F1 as it is equals to m times A. Alright, m times A, that is 1 into A. Now this is the equation 2. Alright, or we can continue this equation 2 to find acceleration, exact acceleration, my dear students. What we can write here, so F is nothing but the mu times mg. Here the mass it is 1, g it is 10, it is A, and mu it is how much? 0.2. So 0.2 times 10, it is A, that is 2 meter per second square. That we got the acceleration. Now, if you are having the acceleration, my dear students, we can put the value of A here to find the force, what we can apply the maximum force, so that this entire system moves with a common acceleration. Okay, now here we have to find the F2 also. And what will be the F2? So the F2 we can write here only. It is mu times m1 m2 z. Alright, m1 m2 z. Now we are having the answer. Alright, we can write here. What we can write, my dear students, from this equation? F minus mu, it is 0.2, m1 m2 it is the 4, z it is 10, is equals to 4a, a it is 2. Alright, could you find the value of F? It is 8 plus 8, 16 Newton. This is the answer. Alright, kindly note down. I hope you understand this question, how to solve. One question I'm going to give you the homework on the basis of this one. Alright, one homework I am giving you. How much maximum force you can apply? Suppose it is 2 kg and this is suppose 4 kg. Here 0.2 and here mu, let me change 0.1. I have changed the data. 0.1 and 0.2. Alright, you have to find the maximum force for which this entire system remain not in equilibrium, but A does not, if this is A does not move over B, but entire system can move with some acceleration. This is your question. Okay, my dear students? Yes. Now, the last question of this lecture we are going to deal. Let me draw the question so that you will try. Then after I'll erase the board. My dear student, this is the question. Two blocks. It is the first block. Let me start from the here. This is the pulley. The two blocks you can see it is connected with a pulley. Alright. Here M1, M2, if M1 is 5 kg, M2 is 10 kg. Alright. And the coefficient of friction it is 0.15. It is given. Of course, it might be the system it is moving downward, it is moving forward, it might be. Then how much mass should be put over here? Okay, what we have to find? M. What should be the mass we should put over M2 so that system stops its motion? This is the question. How much mass we should put over M2 so that motion stops? This is your question. Alright. Try to solve. If you can solve this question, try to solve. Very simple question, my dear students. Remember, this is the very, very simple question. Okay. Now, let me solve this question. Look at here carefully. Here, the M1G, alright, which will produce here the tension T. My dear student, you know that here must be some friction. Suppose it is F. To stop the motion, what should be the condition? To stop the motion, this friction should be greater than or equals to tension. Because here the only tension is the driving force. Alright. It means this frictional force either greater or equals to the tension. This is the hint of this question. Now you can solve this question, my dear students. Look at here. If motion stops, then what we can write here? The tension T can be written as M1G, which is equals to how much? The 5G. Alright, 5G. It is 50 Newton. Alright, it is 50 Newton. Now, my dear students, to stop the motion, F, which is mu times, normal it will be the M plus M2, G, it should be either greater or equals to the, how much? 50 Newton. Now, all the values you are having, mu, M2 and G, you have to find M. Could you calculate? Yes. Then it will be the M plus M2 is equals to 50. For we are getting, if it is not moving, the exact very heavier mass you will put, of course it will stop, but the minimum mass we are going to find here, we should put divided by mu, it is 0.15 and it is Z. Alright. Now, M we have to find, so it is how much? I think with 0 and it becomes 500. So 500 over 15 minus this M2, how much it is? 10. Alright, and this will be the answer. Okay, so this was not very difficult question, my dear students. In this way you have to tackle the numerical of frictional chapter friction. You will get number of questions, my dear students. I have solved here 10 to 12 questions in these two classes, in this two lecture 36 and 37. Alright, because this is very important, that's why I have done. In same way I will discuss the numerical question in maybe 3 to 4 lecture in rotation also. That is also very important. chapter for standard 11 as well as for competition. Okay, my dear students. So this is all about today's lecture, my dear students. Thank you very much.